Now we're going to do out some factoring problems that use the perfect square trinomial factoring. And I'm just going to tell you what to look for to know that you might want to try to use that factoring. So I'll do out two different problems, number 14 and number 16. So first we have factor v squared plus 14v plus 49. All right, that's a trinomial, so we could go ahead and use that normal trinomial factoring if we want to from section 6.3 and 6.4. Or we could look and identify that we might want to try the perfect square trinomial factoring. And the way you identify it is if you have three terms with perfect squares on both ends, the v squared and the 49 are both perfect squares, then you want to try perfect square trinomial factoring. The way you do that is very similar to the difference of squares. You take the roots of the ends, v and v, 7 and 7, and you put them in place, and then you keep the sign that's at the beginning. So right there, whatever your middle sign is, keep it down here. And you see if it works. If it works, you're all set. Basically, you got to check the middle term, because we already know that v and v are going to give us the v squared, and 7 and 7 the 49, because we knew that they were perfect squares at the beginning. So we need to check the middle term. Middle term will get, so check middle, 7v plus 7v. Yes, it works. So that means that this is going to be the right factoring. It'll give us v squared plus 14v plus 49 if we were to multiply it back out. All right, so that's how you can know that you want to use the perfect square trinomial factoring. And usually I just look and see if I have perfect squares on the ends. I try it and see if it works. If it doesn't work, I go to the normal trinomial factoring. Let's try one more. 6.5, number 16. And this is where you can see that this approach can be handy, because if I look at t squared plus 1/3 t plus 1/36, I don't want to try factoring that using the other methods like trial and error or the grouping method. That seems like it would be a bit cumbersome. So I'm going to look and say, hey, that's a perfect square and that's a perfect square. So I'm just going to try the perfect square trinomial approach and see if it works. Square root is t. Square root of 1/36 would be 1/6, because 1/6 times 1/6 will give me 1/36. And then I'm going to keep the sign. So plus 1/6 plus 1/6. And one more thing you want to do when you factor them out like this for your final answer, because they're both exactly the same, you want to show it like that. So on that last one we did, we should have shown it like that too. So now I double check the middle term to see if I'm getting the right middle. So I'm getting 1/6t plus 1/6t equals 2/6t, which is reduced to 1/3 t. Yep, the middle works. So that would be my final answer. And on number 14, final answer would be v plus 7, whole thing being squared.